Hello everyone, in this video we will be doing Cauchy's root test. Let's see the proof of it. First, let's look into its statement. What it says that if series un be an infinite series of positive terms and let this un to the power 1 upon n is equal to L. You know, this is a very unique test, because till now whatever test we have dealt with, it has nothing to do with this power, but in this test we have series which contains power, so you can easily figure it out in your examination which series is this. Okay, now this Cauchy's root test will be satisfied only if the three conditions is satisfied. So the series un will be converges if this L is less than 1. Just look, L is less than 1. Then earlier we have such series which where we have been doing that L is greater than 1, then the series was getting convergent. But in this case L is less than 1, then only series is getting convergent. Divergent if L is greater than 1. So do not get confused between this and let me tell you one more thing. In the previous video I had discussed the Gauss test, right? That was also very unique test. So Gauss test, Cauchy's root test, upcoming test, whatever test I will be discussing in the upcoming videos, these are very unique tests because it has nothing to do with the let it be. So let's see into its proof. Okay, so proof, since this limit un to the power 1 upon n is equal to L. Okay, so here what is this? This is the definition of limits. If it is equal to L, then we can say that it lies between L minus epsilon and L plus epsilon. This is actually the definition of limit, where epsilon is greater than 1. Okay, it's a very small quantity. We can write it as like this. Okay, now if we take, now we will going to take the three cases. First, when L is less than 1, then when L is greater than 1, and then when is equal to 1 L is. Okay, so case 1, when L is less than 1, we can choose epsilon is greater than 0 such that L plus epsilon is less than 1. Okay, from the equality 1 we can say that un to the power 1 upon n is less than L upon L plus epsilon. This is from the definition of limits. We can write it here for all n is greater than equal to m. Now if you shift the power to the RHS side, you will be getting un is less than 1 upon epsilon whole to the power n. Now here now this is a geometric series. Okay, how? See, 1 plus epsilon, then second term will be 1 plus epsilon to the power square, then cube, then 4, then 5, till n terms. So its common ratio is 1 upon epsilon. Are you getting my point or not? 1 plus epsilon is the common ratio. How we can find the common ratio? You have to divide the succeeding term with the preceding term. You will get same value. For example, let's take, let me break down this example only in this side. 1 plus epsilon, 1 plus epsilon square, 1 plus epsilon cube, till 1 plus epsilon to the power n. Okay, now we have to show that this is a geometric series. So I will take the second term first and the first term in the denominator, and if I divide this, I am getting 1 plus epsilon. Okay, now I will do with these two terms, 1 plus epsilon to the power cube plus 1 plus epsilon square. I am getting common ratio as 1 upon epsilon. Likewise, आप किसी भी पीछे वाले टर्म और आगे वाले टर्म का रेशियो करोगे, आपको सेम कॉमन रेशियो मिलेगा. ठीक है, मैं ये क्यों कर रही हूँ? क्योंकि अभी ये पता चलेगा कि ज्योमेट्रिक सीरीज़ क्यों मैं बीच में लाई हूँ. डू यू रिमेंबर गाइज, जब मैं सीरीज़ पढ़ा रही थी तो सबसे पहला ही दिन मैंने ज्योमेट्रिक सीरीज़ की बात की थी, और ज्योमेट्रिक सीरीज़ में भी हमारा कन्वर्जेंस कैसे हुआ था, डाइवर्जेंस कैसे हुआ था, मैंने शो की थी. प्लीज़ आप वो पेज को रेफ़र कीजिए. अगर आप मेरी वीडियो स्टार्टिंग से फॉलो करते आ रहे हो तो आपको कोई परेशानी नहीं होगी. अगर नहीं करते आ रहे हो, डोंट वरी, आई विल पुट द लिंक इन द डिस्क्रिप्शन बॉक्स, आप देख लीजिएगा वहाँ से. नाउ 1 plus epsilon to the power n converges as it is a geometric series with common ratio this, and we know that we have taken that this is less than 1, so this is also less than 1, so this will be convergent. What is convergent over here? The geometric series is convergent, means this series is convergent. So by comparison test we can say that this is also convergent. Am I getting, or is everybody is getting my point or not? So by comparison test we are doing this un is also convergent. It's very simple. If you do not understand, please rewind it, because I have covered each and every point which is to be taught over here. Now case 2, L is greater than 1. Similarly, we will do that un to the power 1 by n is greater than L minus epsilon, is greater than, from the inequality 1 that we have assumed, okay, from the definition of limits. So here un to the power 1 upon n is greater than L minus epsilon. Now un is greater than L minus epsilon to the power n. Again this what has happened over here, this is shifted to RHS side and we left with this again. Now one here, one there's L minus epsilon to the power n, it is divergent as it is a geometric series. So it is diverging. Why? Because L is greater than 1, this is greater than 1, so it is a divergent. If it is a divergent, then this will be a divergent. How? By comparison test. Okay, so this we have proved. Now case 3, when L is equal to 1. So if L is equal to 1, the test gives no conclusion, because the series may either converges or diverges. Okay, such a easy test guys, such a easy test. Okay, so if you have any kind of doubt, you can ask me in the comment section. Till then, take care, stay tuned, bye bye.